Okay, so this problem wants us to draw position versus time, velocity versus time, and acceleration versus time plots. Down here we have all our graphs, and we'll start with position. It says at x equals 0, assume position equals 2 meters. So to find position from a velocity graph like this, we have to take the integral, so that'd be the area under the graph. Each of these boxes represents 10 meters if we were to take the integral. So this one over here would be 5. And since our starting position is 2, at t equals 2, we would be right around there. So that would be 7. And if we were to keep going, we would add on 10 and 5, so 15. 15 plus 17, no, 15 plus 7, that would be 22. 22 at time equals 20, at time equals 4. And even though this graph is going downwards, it is still above the x-axis, which means all of this over here also gets added on. T equals 6, that's another 15. 15 plus 22, 37 at time equals 6. And then at 8 we have another 5. So at 8, 37 plus 5, 42. And at this point you can see that the velocity goes to 0 and actually dips underneath the x-axis, which means he's going backwards. So all of this down here needs to be subtracted. So this would be a negative 5. T equals 10. We would go backwards 5. So t equals 10, we'd go back to 37. Like so. T equals 12. Now we have to go back 15. So that would take us back down to 22. I think that was the number. That would be your position graph. Next, velocity graph. I suppose we'll just copy it right on over. At 4, 10 meters per second. Eight goes to 0, 12, negative 10. And then we go to acceleration. So to get acceleration from a velocity graph, you have to derive. So you take the slope of the graph. As we can see, from 0 to 4, the slope seems to be rise over run, 5 over 2. So that would be the constant acceleration from t equals 0 to t equals 4. And 5 over 2 is 2.5. all the way over there, just like that. We can see that the slope from t equals 4 to 12 all the way over there is actually negative 5 over 2. So this would actually jump off right there. Start again down here. It's about 2.5. And go all the way to 12. Like that. So next up is to create a plausible story for what's happening. We can see that the top speed is 10 meters per second, which is pretty fast. So we could say that you realize that your friend's sandwich was still in your car, and being the good friend that you were, you turn your car around and start driving towards him, accelerating all the way up until t equals 4. At that point, you start to hit on the brakes and slowly coast until time equals 8 seconds. At this point, you've caught up to your friend, throw the sandwich out the window, slam your car into reverse, and start accelerating back the way you came.